Hey guys, just a extension video on balancing equations if you wanted to watch it, so hopefully it's helpful. These are just some of the homework questions, so it should be nice and easy for you to check your homework. Alright, so we're just going to do 4 or 5 of them. We've got this guy here, the first one, A. We've got iron, Fe, metal, and we've got chlorine gas, Cl2, makes iron chloride. Okay, so we've got a metal and the non-metals reacting to make an ionic compound, so iron chloride. I'm always going to keep re-emphasizing that because it's really important. So our job here is just to balance this. So we're going to do a little stock take. Now you may or may not need to do this every time. I'm going to do it just so we can see. So we've got our iron, we've got our chlorine. We're going to do a stock take on both sides. I'm going to draw a line down here. Okay, so at the moment we've got one iron atom. We've got 2 chlorine atoms bonded together. So I'm going to put a 2 there. Remember, that's Cl bonded to Cl. That's a covalent bond, 2 nonmetals. And then we've got, over this side, we've got one iron. In this case, it's an iron. And we've got 3 chloride ions. So we've got a 3 there. Remember, this guy's, he's Fe. Bonded to 3 chlorine atoms, ions, sorry. So negative, 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 3 plus. That guy's an ionic compound, metals with non-metals. Okay, so just a reminder. Not important for balancing too much. Alright, so we've got to fix our numbers. We've got to make sure the lower conservation of mass holds. So our ions are looking good, but our chlorines are not. So we've got a 2 on this side and a 3 on this side. Now that's a little bit tricky. Little piece of advice here: when you've got numbers that don't easily match up, you want to try and find, if I can do this, you want to find a common factor between them. So what do they both sort of, what will 2 go into and 3 go into that's quite small? Common factor here would be a 6. So we want to turn both of these numbers into 6s. So how do we turn 2 into a 6? Well, we times it by 3, and that will give us 6. So up here, we'll put a big 3. And how do we turn a 3 into a 6? Well, we times this one by 2, and that will give us 6. So we put our 2 up here. So when we do that, that gives us, we now are balanced, right? So we've got 1 Fe reacts with 3 chlorine molecules. So the big 3 here says we've now got 3 chlorine molecules, like this. So that means we've got a total of 6 chlorine atoms. Reacts to produce 2 iron chloride. So we're going to put another one of these just so you can see how it works. Remember, these are crystal lattices. I'm not drawing these perfectly, but it gives you an idea. So that's what the 2 does. We've now got 2 of those. So that means we've got 2 Fe's. And we've got 1, 2, 3, 4, 5, 6 chloride ions. So we're balanced. Tick, 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 tick. So there's the first balanced equation. Alright, let's scroll down. And I'm going to rub this guy off. Oop. Alright, got rid of him. So next guy, B, we've got iron metal again, reacting with oxygen gas this time. So we've got iron metal. Remember, oxygen gas is oxygen double bonded because I need to fill those 2 outer shells, or the outer shell with 2 electrons each. And we've got iron oxide here. So we've got a metal and a non-metal. We've got another ionic compound. So I'm not going to draw that. He's too complicated. But for every 2 ions we've got 3 oxygen or oxide ions. So we've got to balance this guy. So let's do our little stock take again. So we've got iron and oxygens on this side. We've got 1 on this side, and we've got 2 oxygens. On the product side, we have 2 Fe's, and we've got 3 oxygens. Okay, so we've got to make these numbers equal. We've got to make them balanced. The way we're going to do that is we're going to start with our iron. We've got 1 on this side and 2 on this side, so we can put a big 2 in front. Remember, we can't put little numbers. That's wrong. Okay, we can't change the little numbers. Little numbers lock in the molecule to what it is. So iron oxide is always Fe2O3. It cannot be Fe3 O3, that doesn't work, the charges don't balance, we can't change the little numbers. So when we're balancing, just a reminder, always just the big numbers, the coefficients at the front. So that big 2 there says that we've now got 2 Fe metal atoms. I'm just going to draw them in. And that cancels that to a 2, which is good. And so we're balanced. We're happy with the ions on both sides. We've got 2 ions on each side now, which is great. The oxygens, we've got 2 on the left and we've got 3 on the right. Again, one of those funny 2 and 3 combos, so we need to turn them both into the lowest common sort of factor, which is 6. So I'm going to times that by 3. That means we're going to have 6 here. So we need to have 3 of those oxygens up there. That big 3 tells me I'm going to have 3 oxygen molecules, 1, 2, 3, with 2 atoms each. So there's 6 oxygen atoms total, which is good. And over here, we've got 3 oxygens. We need to turn that into a 6 as well, so we're going to times it by 2. So that means that we need 2 of these. So we've done that. So we've now got 2 times 3 for oxygen. So we've got 6 oxygens on both sides, which is great. The one problem we've done here is obviously that we've also, the big 2 times it multiplies both the iron atoms or ions and the oxygens together. So we've fixed the oxygens, but now we've screwed up our iron. But that's okay. Got to do it. So 2 times 2 is 4. So we've ended up getting 4 Fe's on this side now. So we need to come back over to the reactant side and fix that. So we've got 2 on the left and we've got 4 on the right. So we're going to have to actually rub out this coefficient. And what are we going to have to make him? Make him a big 4, right? If we make him a 4, that means we've got another 2 Fe. So we've now got 4 Fe atoms on this side, and we've got 2 times 2, we've got 4 Fe ions on this side, so we're balanced. So that's good as well. So we've now balanced the Fe's, and we've got 6 oxygens on this side, and we've got 2 times 3, we've got 6 on this side, so we're balanced. Nice and easy. Alright, let's scroll down. We can do the third one. We're going to have to zoom out a little bit. Okay, try and get rid of that. Alright, so this time, number 3, or C, we've got 1 Fe here, we've got 2 Fe's here. I'm not going to do the stock take this time, let's just see if we can do it without a stock take. So we've got 2 there and 1 there. Always start with the metals if you can. So we're going to need to put a big 2 here. That gives me 2 Fe's and 2 Fe's. That's good. Next, let's check the bromine. So we've got Br, we've got 3 bromines. Alright, the little 3 is attached just to the Br. So we've got 3 on this side, we've only got 1 on the product side. So we're going to need to have a big 3 here. That will give us 3 bromines on either side. So that's good. So the bromines are balanced, the Fe's are balanced. Now let's come to the sulfur and the oxygens. Now here's a little helpful hint. SO4 is actually a polyatomic ion. Okay, that's called the sulfate ion. If you go back and check your common ions table from previous videos, you'll find that that's actually an ion. Those things, the sulfur and the 4 oxygens go together to make a sulfate ion. We've also got sulfate ions here. Now you can balance the individual atoms. You can balance the S's and then the O's. But in this case, because I know that that's a sulfate and I know that that's a sulfate, I'm going to balance these as sulfate ions rather than individual atoms. That just makes it easier for me. Okay, so I've got 1 sulfate ion here that's made up of an S, an O, and 4 O's. And I've got 3 sulfates here. That little 3 tells me I've got 3 of whatever's in the brackets, and what's in the brackets is a sulfate ion. Okay, so together I've got 3 sulfate ions here and only 1 on this side. So that means I'm going to need 3 sulfate ions on this side. So that 3 says I've got 3 sulfates now, which balances my 3 sulfates here. The last job I've got to do is balance the hydrogens. Okay, so I've got 2 on this side, but I've got 3 of these, 3 times 2, so I've actually got 6 on this side, I've only got 3 on this side. So I'm going to have to come back over here and actually rub this guy off. And so I'm going to need 6 hydrogens, because I've got 3 times 2 is 6, now I've got 6 there, that's great. But remember, that 6 now also means I've got 6 bromines, so I've got to come back over to the left side and go, okay. And I have already got 6, which is great. 2 times 3 is 6 bromines, so I've actually got 6 on that side as well, which is fantastic. So that looks balanced to me. You can go through and do a quick check. We'll put a 1 here, just to make sure we're all good. But yeah, that looks balanced. So there's a little helpful hint. Balance polyatomic ions together if they don't change from the reactants to the product side. Makes it a bit easier. Alright, number 4, or D. We've got 4 carbons, so I always start with carbons, leave oxygens, hydrogens till last. We've got 4 carbons on the left side, we've got 2 on the right side. So I'm going to put a big 2 here, because 2 times 2 is 4. That balances my carbons. Now let's have a look at what we're going to balance. It doesn't matter which we pick next, I don't think. So let's balance our hydrogens. So we've got 6 hydrogens here, plus another 2 here. So we've actually got 8 on the reactant side. And we've got 2 times 4, which is 8, so the hydrogens are actually balanced, which is great. Let's check the oxygens. We've got 3 here plus 1 here, so there's 4 on the reactant side. And we've got 2 times 2 is 4, so it's actually balanced how it is, which is fantastic. Easy peasy. Alright, last one. C2H4 reacts with oxygen. This is a combustion reaction, makes carbon dioxide and water. Okay, so 2 carbons this side. We're going to need 2 carbons on this side. We've only got 1 so far, so we put a big 2. Lastly, what else do we need to do? Let's do the hydrogens next. So we've got 4 hydrogens on this side. We've only got 2 on this side. So we need to put a 2 here, because 2 times 2 will give us 4 hydrogens, which is good. Makes the hydrogens balanced. Last one. We've got 2 oxygens on this side. We've got 2 times 2 is 4, plus another 2. We've actually got 6 on this side. So what number am I going to have to put here? Put a 3. 3 times 2 is 6. And that looks balanced to me. So you can do a double check. 2 carbons, 2 carbons. 4 hydrogens. 2 times 2 is 4 hydrogens. 2 times 3 is 6 oxygens. 2 times 2 is 4, plus another 2 is 6. Just for those who are interested, that's ethene. That's a molecule ethene. There's 1 of those. There's 3 oxygens. That's what the big 3 means. There's 2 carbon dioxide molecules. And there's 2 water molecules. Alright, so if you're a visual person, it might be better to do that. You can count up all the carbons and the hydrogens and the oxygens, and you'll find that they are all balanced. Alright guys, hope that was helpful. Yep, catch you later.